and I welcome you on slot 6. The sector is materials and constructions. So let us welcome our judges. Okay, the first one, Philip von Klitzing from Joint Capital. Jan van Leuven from ZX Ltd. Sorry for mispronouncing that. Maxime Paradis from Genius Global. And Tomasz Józefatski, a partner of Funding Box Deep Tech Fund. And let's just proceed with the first startup right away. So SpinDrive, Nikita Urzagów, hello.
Hi, my name is Nikita, and I'm co-founder of the Finnish company SpinDrive. And SpinDrive reduces rotating equipment lifecycle costs by 35%. Around 40% of the electricity worldwide is consumed by rotating electrical machines. However, these machines are not efficient from the process perspective and require massive maintenance. Original equipment manufacturers, or OEMs, would like to improve their process efficiency by switching to the higher rotational speeds. However, the OEMs are missing in-house expertise to design high-speed bearings, and bearings cause around 70% of all failures in these machines. Solutions available on the market are not flexible and extremely expensive. In SpinDrive, we address this 24 billion euro special bearing market problem by providing active magnetic bearings. And magnetic bearings consist of the controller, actuator, and sensor, and they are levitating the rotational part of the machine, completely eliminating friction. They have a similar operating principle as the maglev train, but for rotating machinery. And with our solution, the system efficiency is increased by at least 10%, which allows 2-year payback time. Our system is completely maintenance-free and oil-free, which allows an access to the new markets. And with our built-in sensors, we are ready for condition monitoring from day one. So overall, SpinDrive reduces customer equipment lifecycle costs by 35%, and retrofit solution is possible. SpinDrive impact goal is to democratize levitation technology to mitigate above 0.5 gigaton of CO2 emissions by 2050. We are positively affect the lives of more than 1 billion people by mitigating CO2 emissions, helping to provide contaminant-free food and water, make renewable energy accessible, and replace ball bearings with the magnetic levitation in mass market applications. Our target, our business model is that we provide the magnetic bearing unit to the original equipment manufacturers as a transactional mode, and after sales, we provide condition monitoring as a recurrent-based revenue. And the first target market applications for us are turbo blowers, turbo compressors, and flywheels, where the market size is around 3 billion euros, with our beachhead market being in turbo blowers. Also, our next markets include hydrogen utilization, electric airplanes, and fusion power, to name a few. And our traction, we raised our seed rounds. We have paying customers in Europe and Asia, and LOIs for more than 5 million euros of annual unit deliveries. Our team has 4 co-founders with an extensive background in magnetic bearing market and technology, and we rely on international experienced advisors. We're looking for a 2 million euro round to sell 200 units in our target markets, and 45% will be used for sales and marketing. So I guess that was 3 minutes, so thank you very much.
Yeah, that was perfect timing, to be honest. So let us go into the Q&A sessions. 4 minutes are yours. Judges?
I can start. Thank you, Nikita. Very interesting. Could you maybe elaborate on the go-to-market in the next couple of months or years? That would be interesting.
Yeah, absolutely. So, okay, I think you cannot see my slides anymore, but currently we are finalizing the field tests with the pilots and customers. And the next step for us is to finalize the CE marking of our units. Our first serial product sales will start with the turbo blower application. It will be in summer this year. All the, let's say, piloting tests are done for this market. And the next one will be the flywheel market also this year. We will aim for more than 2 million euros of product sales in 2022 for at least this couple of first target markets.
This is Tom. Thank you. Can you elaborate a little bit? How you go into relationship with your customers. What it means in this case to sell. Is it a licensing? Is it subcontracting? Are you going to actually?
No, we actually
components.
Yeah, we actually provide the product. So what we provide is the system as the kind of transactional model. Our Burin system is the part of the customer equipment. And typically there is a series of product what they have. So it's something like from 20 to 200 units per product series what our typical customer have. The sales process starts with some kind of piloting. So we test our solution at the within the customer unit, and then we go into the serial production.
Okay, thank you.
Myself, I would like to know what is the fundraising for? What are you going to do with the fund?
Yeah, so as I briefly mentioned, 45% will go to the sales and marketing. So we are basically expanding our sales efforts as we have quite pretty established the pipeline of the potential customers. So basically, we are finalizing the developments and go into the serial production of the units and serial sales to the prospects which we have at the moment.
Nikita, thank you for the presentation. What valuation are you raising at now?
So pre-money valuation we're targeting is 10 million euros, and we're happy to discuss that.
Okay. Okay.
And we have 1 minute left, so maybe any other last-minute questions?
Maybe on the team, could you tell us a little bit about your expertise as a team before SpinDrive?
Yeah, so if you can allow the slide here. Well, our background, we've been all working at some point at the Finnish university, and also our co-founder has been working in some tech companies here in Finland. Basically, we are commercializing more than 35 years of research behind SpinDrive, and we've been able to attract the, let's say, the best talents on the sales side as well. So our sales are currently led by the professional with more than 25 years of experience in B2B sales to OEMs and other experienced guys as well.
And that's the timer has just rang, so we're out of time. Thank you so much, Nikita, for your presentation.
Thank you very much.
Thank you.
Thanks.
Make sure to connect with judges and other people on Hopin and Wolf's Match. So let us move on to Coated. Katarzyna, are you somewhere here? Perfect. Hello.
Hello, hello.
Can you show your presentation?
Good afternoon. Can you see my screen?
Yeah, I can see your screen. Let's go to presentation and full mode.
Great. Hello, everyone.
Perfect.
Let me start with the small story. It's October 2016, Nebraska. One of the pipes transporting ammonia corrodes and releases gallons of toxic gas. This forces evacuation of nearby homes and closure of roads. The necessary repairs cost thousands of dollars. Not to mention $3.6 million, which company operating the pipeline had to pay a few years back due to another ammonia spill, which caused death of 20,000 of fish in the nearby lake. Unfortunately, the 2016 accident took another toll. One person died due to exposure of toxic fumes. Corrosion, as you see, can cause very serious problems, and those problems are global. Corrosion slowly eats the chassis of your car, can cause water leak on your street, or can stop operation of chemical plant. It is estimated that each year we need to pay $2.5 trillion because of the corrosion. My name is Katarzyna. I am CTO and co-founder of Coated, and today I want to share with you our solution to corrosion problem. We developed a technology of nano additives, which could be easily implemented into existing coating processes. Our additives significantly improve the anti-corrosion and mechanical properties of materials. But what more, we can bring to the materials new functionalities, such antimicrobial, self-cleaning, or superhydrophobic. What is more, we are able as well to detect corrosion and wear, so a lot of accidents may be actually avoided before they happened. And you know what? It works. We got the coating which got more than 60% higher hardness and much better corrosion resistance. We as well managed to make superhydrophobic coatings which repel dirt, water, and ice. Since our technology is quite versatile, it could be used everywhere where safer, more durable, and sustainable solutions are needed. And the market is quite big. If you think that we can cover just 5% of abrasion-resistant coatings, we talk here about the $100 of millions. And since there is no the same solution on the market at the moment, we got quite big interest in our technology. We managed to secure funds from two sources, private and public one, for extended R&D work. Within 1 year, we should be ready with the first pilot batch production. Once we achieve this stage, we can start to sell our products or license them. At the moment, we are running the discussions with the coating suppliers and end users about running the field trials with us. And people behind it is a team which includes researchers with deep scientific knowledge and years of academic and business experience. People who know how to bring products to the market, and administrative support. When running Coated and developing our products, we really care about environment. We care about your safety, and we want you and your clients to save money. So what to say more? Just Coated, and contact us if you are interested.
Okay, thank you for your pitch. And now we have 3 minutes, 35 seconds for questions. Judges, your turn.
Yeah, thank you very much for this pitch. My first question is, what will be the business model that you have in mind for that?
So we have two options here: or we make the product, we start production and we sell it, or we license the technology. So somebody who has ability to actually produce the product themselves, to produce the additive themselves, they can start doing it by buying the license from us.
So what about IP? What is the IP behind it?
So part of the IP, we filed the patent for it, but a lot of the things are the trade secret. This is the strategy of our company. We don't want to make all our knowledge public, so some of the things are just the company secret.
Okay. This is Tom. Can you speak a little bit to your competition? I can probably, I'm not the expert in the area, but I can think about at least few companies that specialize in this space. And these are huge multinational companies that operate globally, and they have a secure channels of distribution. So how you want to go against them, and who you consider a competition?
Mm-hmm. So as a competition, we think about the people who make the coating additives. So the companies like Carbodion, Conventia, those are very big names in the protective coatings. However, none of those people can do everything what we could do. So actually, they cannot obtain the solution which could give you very good mechanical properties, very good anti-corrosion, plus additional functionalities. Plus, what we do here extra to make it possible to detect corrosion before actually the final failure of the material. What more, our competition, if they have some solutions, they are solutions very dedicated to specific coating. Okay. For example, Carbodion makes nanodiamond, and nanodiamond can make your coating super hard, but actually it doesn't provide you any anti-corrosion properties, not talking about any other functionalities. And as you can imagine, nanodiamond is pretty expensive. So it costs around 250 euro per few grams of it. And our solution will be much, much cheaper. So it's combination of our elasticity possibility of making our solution tailored to many possible applications, many possible coding solutions which are out there, plus our price tag, which is much better than the one which competition has.
Hi, Katharina. Thank you for the presentation. I'm interested to hear from you. Are you looking to raise funds? And if you're looking to raise funds, can you tell a little bit about what you're looking to raise and what it's going to be used for?
So within next year, we don't look to raise any funds. And I mentioned we already managed to do it in the pre-seed round. We secured around 2 million of Polish zloty from two sources. So at the moment, we don't look for it. We have as well quite big interest in our technology. So we hope that within next year and a half, we should go commercial. So hopefully then we will not need to look for funds. If something, then at this point, we could look for some new investments.
Thank you so much, Katarzyna. So sorry to interrupt all of you, but you have to continue on Hopping or Wolf's Match. But for now, we have a new startup. Thank you, Katarzyna, for your presentation, your pitch.
Thank you a lot.
Thanks. So next on, Exatech, Volkasinov, welcome. We can see you, we can hear you. Please share your presentation. Thanks.
Okay, thank you very much for the introduction. And yes, I like to, no, it does not work. Why not?
So you have to click a little plus with a display underneath our videos, and then you're gonna have like a screen with different suggestions. So you have to click on the screen, and the button is gonna be
yes,
blue.
I click share, but it does not open the file that I want to open. Let me just check. So, okay, now we are. Here we are. So I hope you can all see my screen now after.
Just a second, it's loading. Yeah. Can you go to the full screen mode?
Yes, I can for sure do that. Okay. So now it should work. Can you see the slides?
We can see the slides, but it's not in the full screen mode.
It should be. I'm in the full mode.
The other thing you can do is you can turn off your sharing of the screen, go to the full mode, and only then share the screen once again.
Once again, so now, does it work now?
No, not really. Would you like to proceed with those slides or try once again after another startup?
Let's do it that way. So
okay, so you have your 3 minutes. The floor is yours.
Okay, thank you very much. So we are talking about the growth of compound semiconductors. You will ask, hey, compound semiconductors, what's that? But you are very familiar with this type of material because the light-emitting diodes are manufactured out of it. But of course, there are a lot of other markets, multi-billion-dollar markets with double-digit growth rate per year, which we like to address, starting from high-power electronics over biotechnology, 5G with bulk acoustic wave filters, and ending up with novel displays. When you take a closer look at the different industry, you will see that there is one common pain point, and that is and these are the costs. Why is this the case? So when you, the current technology which is applied, that is MOCVD. It's a very complex process which runs at temperatures higher than 1000 degrees Celsius. And the process is that complex that you are not able to increase the efficiency significantly within the next years. The manufacturers of those systems, they run into physical constraints. We follow a complete different approach. We have developed a combination of PVD and CVD technology, which drops the temperature down to 300 degrees Celsius. And despite the low temperature, we are able to achieve still single crystal quality. And the big advantage is, of course, that we are able to increase the capacity by a factor of 10, and that we are able to lower the cycle time by a factor of up to 7. Here you see our life-sized prototype. And another advantage is that we do not have any geometrical constraints. So we can, as you can see on the left-hand side, we can even go to rectangular shaped substrates. And moreover, due to the low temperature, we can also work on temperature-sensitive materials like glass and deposit the material directly on the glass, which is of big advantage for the new generation of micro-LED displays, for example. We have two business areas. One is the supply of machine systems for starting layers, and the other is the EP house approach, where we will supply wafers to our customers in the area of bulk acoustic wave filters, of transistors, and of micro LEDs. The big advantage, as already pointed out, is the disruptive cost advantage. Here, a comparison for a 200 millimeter wafer manufactured via MOCVD or manufactured via our low temperature epitaxy. And you can see that we are able to drop the costs by more than 90%. So it's a big advantage and makes the technology very attractive for customers. We want to enter the market with our template tool in the early 2022 and start with the manufacture of the EP wafer in 2023. Currently, we are organizing a financing round with a volume of up to 7 million euro. A large portion of this money is already granted. And on the back of this funding, we will go for a government grant of up to 10 million euro, where the perspective is also very promising. The proceeds will be used to start the serial manufacture of the template production tool, and we expect a return on investment with a multiple of 4 in 3 years by spinning out the technology in the bulk acoustic wave filter area, and with a multiple of 8 in 2025. That's it from my side. I'd like to invite you to be part of our exciting journey, and well, I'm open for questions. Thank you very much.
Okay, so we got a bit of time from the Q&A session. You have 3 minutes, 21 seconds. Judges, go ahead.
Thanks a lot. If I can go first. As many of us know, there is like a global shortage in a semiconductor. So my first question would be, how do you integrate in that international context? And is that an opportunity for you? And how do you put yourself into that context?
Yeah, so the big advantage of our technology is that we do not substitute the technology which is applied today completely, but we will add our template tool in the front end of the MOCVD machines. And by doing that, the customer can reduce the capacity on the MOCVD machines by around about 30%, and he is able to reduce his costs just on the starting layer by around about 30%. And that's a big cost advantage when you think especially of the LED business, which is highly competitive. So this is low risk for him since he does not change his supply chain. On the other hand, with respect to the bulk acoustic wave filters, which will be manufactured also on the same machine, we see a big need for a new technology because all the filters are moving to high frequencies. And in this context, aluminum scandium nitride will be used. And there is currently a lack of a technology which supplies those filters with a high homogeneity and with a high quality. So they are really looking for epitaxial systems in that large area.
I've got one question, Volker. Actually, so the competition, is it like, you know, semiconductor machinery companies like Applied Materials or you know, LAM Research, or is it actually the you know, the wafer fabs at Seagate or Micron, for example? Who's the real competition for you?
So the competition is, of course, with the MOCVD systems in the end. But as pointed out, so we see a risk that our technology will be copied, especially in Asia. And so we like to restrict the access to our technology by just supplying the template machine, which can be delivered as a black box. This machine will just produce one layer. So they would just have to press one button, and they don't have to go to the process level to run the machine. The other machines will be placed in-house, and in that place, of course, we compete with Seagate and companies like that in the end. But of course, we see a big interest from customers also in Asia. So we had talks, for example, with TSMC, a large company in Taiwan, who have a big interest in sourcing this type of wafers, not from China, but from well, in this case, we are in ideal position in Europe when you look at the political landscape currently.
Hi, This is Tom. Can you speak? I see this solution is quite developed, and I'm curious. Can you speak to the strength of your team? What is your kind of relative
Well,
strength?
we are currently hiring, so we have got team members who have got a lot of knowledge in the MOCVD area. They were with Extron. And
Walker,
currently
sorry,
we
I'll have to interrupt you since we are run out of time. So I suppose you're
sorry.
gonna address this question. No worries. Gonna address this question in Hoppin or Wolf's match. So I'm sure you're gonna have plenty of time to talk to Tom. But for now, we have to move on to the next startup. Thank you so much for your pitch. And next on, NanoC, Adam Kadziała. Are you with us? Perfect. Can you share your screen? We can barely hear you. Maybe you can move closer to the mic.
Do you see my screen?
No, not yet. And even more, we cannot hear you. We can barely hear you.
Yeah, it stopped. The transmission stopped. Okay, now? How about now?
Well, still, I'm not able to see your screen. So,
Okay.
have you? Okay, yeah. Can you go to the full mode? Full screen?
I prefer to go like that.
Sure, absolutely. So in that case, the floor is yours. 3 minutes.
Okay. I represent NanoC. We are a nanotechnology startup from Poland. We have developed and patented photocatalytic layers for air purification. We manufacture 2 different materials that are used to disinfect air in offices, schools, buses, elevators, and many other places. The technology is not the breakthrough itself because photocatalysis was invented in 70s in Japan. But the difference we made the material which is cheap and easy to use. Together with electronic devices that we design, LED modules and drivers, we are able to cut the energy needed for the process in, let's say, most popular devices like air purifiers on the left by 8 times. We also achieve 3 times longer lifetime of the device because currently used UVC tubes, they have 8,000 hours lifetime, and LEDs we use have 30,000 hours. We are able to kill viruses, bacteria, other pathogens, and currently we're working with, for example, Solaris Bus and Coach, and we're developing system for treating the air inside of the bus to keep the passengers safe from COVID-19, as well as the driver from the products of smoke in the cities. Let me show you an example of the device. That's the front box. So this is the, let's say, HVAC unit for the bus, for the driver compartment. The great thing is the nano layer. Lighten up with LEDs have very high efficacy with high speed of the air transmitted in the module. But our first market product is what we called photocatalytic engine, and this is the shortest path to put the layer on the market in the area where it's needed the most. So treating the air in schools, offices, and hospitals where people meet and they transmit COVID-19. So the engine consists of a layer with LEDs. We use for that UVA 365 nanometers LEDs, and it's lit up from both sides. So the air is then so fixture manufacturers can use it, swapping what they are using now. So UVC tubes and two UVC tubes with a power of 36 watts each. They translate into our device with a power of just 9 watts.
Just wanted to let you know that we are already in the Q&A session. So would you like to proceed with speech or?
I would like to have questions, please.
Sure. So you have 3 minutes, 20 seconds. Judges?
Thanks for the pitch. Have you had the chance to have a pilot with companies yet?
Yes, we are in the middle of the pilot with Solaris. So that's the device for the bus. And we delivered already to one company that builds air disinfectant devices, and they come back to us with a feedback from a laboratory showing really good results. And next lighting companies are in the line waiting for prototypes from us.
And what this is Tom. What business model you're testing with them?
So our business model is to manufacture the layer. That's for the industry like lighting, automotive, or HVAC, ventilation. But for bigger companies like chemical companies, we can give them license for the technology and transfer the knowledge also.
Just letting you know, we have 2 more minutes, so if there are any follow-up questions.
Maybe also, what were the key learnings with that pilot? And maybe how do you plan to scale the production, maybe with partners, industrial partners?
Currently, we have a capacity in our lab to manufacture about 2,000 pieces of this size of a layer. It's 10 by 10. So that the capacity is like it's a need for one client that's manufacturing needed device in Poland. So with another client, we'll just rent a space and make more places for the production, because it's manual now, but it's not that labor intensive.
So I see there's no more questions. So you have 1 more minute, Adam. Just maybe some last final words that you forgot to mention during your pitch. Go ahead.
Sure, I can show you how the devices look like in tests, because hopefully this is what you're gonna see really soon in your offices. So this is the layer inside the test.
For now, we cannot see your screen. Just letting you know.
Oh, sorry guys. So this is how the layer looks when it's lit up by LEDs. It has this starter glow, let's say. Basically, the devices that will use it will be very simple. There's the ventilator in a chamber or a pipe, and at the exhaust side you get air without the virus. So we'll be able to put this put our engines in many kinds of devices, lighting fixtures, tower air purifiers, or just usual HVAC in our offices. We also have another material, which is, and it's also patented by us. So that's the TO2 nanotubes growed on titanium foil.
Okay, so this time, sorry to interrupt, but this time this is it. So thank you so much. Thank you for your pitch. I hope you're going to connect with everyone on Hop in or Wolves match. So for now, we're going to be joined by a new startup, Crystalline Semiconductor. Ariel, are you here? Okay, you're already on the screen. Yes. Can you please share your screen? Maybe turn on the camera if you wish.
Okay, can you see my screen?
Yeah, you have 3 minutes. Take the floor.
Hello, good afternoon from Israel. I'm Ariel, the CEO of Crystalline Semiconductor, and we are dealing with diamond technology.
Sorry,
What?
I'm so sorry to interrupt you, but it seems that something is wrong with your pitch, since we can see your presentation like in a mirror-like way. We cannot read it or
Oh,
actually
well,
see anything.
so what? I don't know what to do with that because I can see it properly. Let's see now. Maybe I'll just skip the words and point you to the pictures. So I will explain everything because I don't want to waste your time, and I don't know how to change the screen
Sure.
direction.
In that case,
Okay.
once again, the floor is yours. 3 minutes.
Okay, thank you. I am Ariel from Israel, Crystalline Semiconductor. We are dealing with diamonds technology. And what we do, Crystalline is a startup based in Israel, is developing a system and method to grow pure and doped diamond crystal wafers, single crystal wafers. Those crystal wafers materials deemed to be the next generation of semiconductors and related applications. Our technology is purely green, fast, efficient, and relatively cheap, and with pricing compared to any other semiconductor in the market. And why we are aiming on diamonds? The semiconductor industry is ruled by the silicon, and few more very expensive and compound materials. As you can see in the chart here, I hope you can see it, this diamond as material has very good properties in like in superior band gap, breakdown field, electron mobility, thermal conductivity. So actually this material is the best material on Earth in many properties, but there's no use in such materials. There's no use in such materials. Our goal is to bring such materials to the market, doped so they can act like semiconductors, and undoped only to the materials environment. Those materials will be the base to next nanotechnology, microelectronics, and electronics in a computing industry. Those materials will bring best physical performance, like thermal conductivity, heat resistance, electron mobility, etc. And why is not used today? Today, the systems that enable the producing of diamonds suffer from low rate of deposition. The diamonds are non-homogeneous. A lot of crystal dislocation issues, and it's very high to product them. So there's no use in diamonds in today's industry. Our solution and actually the revolution is a system that looks like, if you know CVD, but it's not actual CVD. Instead of evaporating in the positioning of atoms, we are producing nano diamonds within the plasma and putting those diamonds on the substrate. So we're building a diamond very fast and very efficient. A technological breakthrough where we can build diamonds very quick, control process, no nucleation seed, top quality, eco-friendly, and at the end we will have single crystal diamond. I heard the bell, so I understand it's a time to Q&A, yes?
That is correct. You still have 3 minutes, 39 seconds. So judges, any questions?
Yeah, hi. Thank you
Yeah.
very much. Who's the actual end buyer in that sense?
Who is the actual empire? What do you mean by empire?
Yeah.
The biggest players?
No, the end buyer.
The end buyer. Oh, that's a good question. Actually, we have a line of buyers for our first product that contains very big companies like Intel. We are working constantly with Intel. They have a big facility in Israel, with Infineon in Munich, Toso from Japan, if you know, it's a very big company. Those companies are producing materials and units to the semiconductor industry, and they need our materials, first of all, in order to produce better equipment with better heat resistance. Our materials enjoy the best heat resistance in nature. So, for example, Intel wants to cover her future chips with such materials in order to reduce to replace heat sinks and reduce the heat on the chip. So we have a very big market to those materials.
Hi, Ariel. Thank you for the presentation. Can you tell us a little bit about where you're at with the patent process?
Yeah, we got funded by the Israel Innovation Authority. We've built 2 prototype systems. We proved the ability to grow single crystal wafers without the nucleation seed. And if we didn't have the corona and our lab wasn't closed due to some legal restrictions, we've been in product at the first in January of this year. Unfortunately, because of the corona, we have some delay with product, and we believe what will be in the product within 3 or 4 months.
This is Tom. Ariel, how do you plan to sell this ultimately?
Sorry?
How do you plan to sell it? How do you plan to sell it?
We're going to sell the materials as wafers per inch. So the pricing will be according to the material size. The market need is between 2 to 6 inch diameter and approximately 100 microns thickness. And they're willing to pay from the large marketplace. So it actually has very short and very fast way to the market.
Is there anything else you would like to ask? Because I also can see that we have a presentation in normal, let's say, way. If you want maybe, Ariel, to show us something one more time, you still have 40 seconds to do so.
Okay, so we'll continue in my presentation. Just to understand, the next generation electronics will enjoy 5 times transistor efficiency, 20 times better heat conductivity compared to silicon of today. It can minimize transistor nanotechnology sizes. And just to explain the working temperatures of those materials, silicon is up to 50 degrees, we are to 300 degrees Celsius. We have future applications because those materials enjoy from excellent properties. So we plan to build energy storage devices, PV cells, based on those unique semiconductors. Thank you.
Thank you so much. Thank you for the presentation. It was very nice to hear you. Bye. Let us welcome the next startup, Nanosyn. Bartosz Kruszka, are you with us? Yeah.
Yes, I'm here. Hello.
And let us try and share your screen then.
Okay.
Great. So are you planning to go to the full screen mode, or we leave it like that?
No, full screen. Wait. Oh.
Yeah, perfect. Okay, so you have 3 minutes. The floor is yours.
Okay. Oh, sorry.
No worries, the clock has stopped. 3 minutes.
Okay, thank you. Hi, I'm Bartosz, the CEO of Nanosyn, and I want to picture a situation for you. Imagine if tomorrow we cure cancer and in 100 years, 1 million kids were still dying of cancer. It will be unthinkable. But that's the situation we find ourselves in with water. The UN estimates that by 2025, almost 2 billion people will be living in water stress regions. The water crisis isn't looming, it's here now. But not acting soon enough, we set ourselves up to fail. That's why we made the NanoSynex water filter. Such solution is the only one in the world. What it does is it desalinates and purifies water using simple filtration process. What makes it different from the existing solution is it doesn't need energy supply nor pressure, meaning it's cost effective and can be used everywhere. Replace large, costly filtration plants that need energy supply, are eco-friendly, produce zero emission of carbon dioxide, and have desalination level control. In this slide, we present some details of industrial and domestic water filters. Filtration velocity for industrial is 180 liters per day. For domestic, 1.5 liters per hour. Cost of membrane replacement for industrial is $1.5 and domestic $0.25. Cost of single installation is $350 and domestic $40. We can purify all types of water in the world. Wastewater from homes, cities, industry, brackish water, groundwater, and of course, seawater. Desalination cost is a main technology in the world where we can desalinate water. And the most popular is reverse osmosis, multi-stage flash. And here we have NanoSynex water filtration. And we don't use electrical and thermal energy. And market in 2020 is $12.8 billion, 2027, $25.7 billion. And the growth rate is 9.5%. From 2020 to 2025. And NanoSynex business model consists in the exclusive licensing to interested company per continent in exchange of upfront fee and royalties. The license will allow partners to produce the solution. All we need is $3 million to develop that technology. For example, increasing multiplication of filter usage, reducing the cost of NanoSynex water purification process, and watching the water crisis ravaging our countries will be heart-wrenching. Why don't we work hand in hand to never let it happen? Thank you.
Okay, so just letting you know that we are already in Q&A session. You have 3 minutes, 25 seconds to go. So judges, if you have any questions, go ahead.
So I understand you're raising money to develop your product. Do you have already some prototypes? Have you already tasted?
Yes.
How far from product market fit?
We have 2 prototypes. For one is bigger. This is in this one slide we presented some details for this bigger industrial. We called this industrial filters. And the second is the smaller one. We presented these prototypes. We have 2 movies in YouTube, so you can see how it works. These details in slide in this presentation we presented how much is velocity of this prototypes. This is a first prototypes at the moment, and we want to find some business partner to introduce this technology and this product in market.
Hi, Bartosz. Can you tell us a little bit about the IP and how you plan to protect it?
So at the moment, we haven't got IP. We have only know-how because this solution is very fresh. It's have few weeks, and with new business partner, we want to do this IP. But now we want to present our innovative breakthrough solution.
Okay, this is Tom. Can you speak also to your team? Who you have on the team that makes you unique in terms of the competencies to scale it?
In our team, we have scientists from Poland. We have 8 people in team, and in this company, I have one business partner. No business, but this is my wait.
Okay, my question is also about unique skills, because this is a very challenging problem to do it also at the quality that you need to have a drinkable, potable water. So do you have any unique skills on the team?
Unique skills. Yes, I have the skills because I'm studying chemistry, nanotechnology in Toruń, and this product which we obtain, it's based on my experience when I worked at Nicolaus Copernicus in Faculty of Chemistry.
Okay, and thank you, Bartosz, so much. That was a lovely pitch. Thank you so much for joining us. Thank you for devoting your time. When it comes to judges, I mean, we have 9 minutes left, so maybe you want to do some reversed pitch. So each one of you have like 2 minutes to tell about yourself, or maybe a company, or what you look for. What do you think about it? Jan, can you tell us a couple of words?
You put me on the spot there. I actually don't really have anything here to add at the moment. Sorry.
Okay. So if anyone wants to share what they're looking for, I'm more than happy to hear that. Okay. So in that case,
I can. No, I'm just So I am a partner in Deep Tech VC. We are a small player in the Polish market. So, but we're definitely looking for, and I think this was a very good panel, quite interesting ideas. This is exactly what we're looking for. Also, other spaces other than construction and kind of deep infrastructure. We also look into technologies such as robotics. Robotics is another interesting space for us in terms of how you can leverage that, and also the healthcare, specifically on the life science area. So these are kind of the 3 verticals that we're looking for.
Awesome, thanks. So I see that Maxim, you unmuted yourself, so I'm more than happy to hear what you have to say.
All right, well, thanks Anna, and thanks World Summit for inviting me, and congrats to all the great founders we just heard. It was really interesting. A bit about myself and my company. I'm Max. I'm actually an entrepreneur and business angel based in Paris. So basically, I've supported a few dozen early stage startups to scale in Europe for the past 3 years since my last exit of my company. And I've just launched actually G Ventures right here, which is the first student VC fund in France that is actually investing pre-seed money into ambitious founders across Europe. So basically, if you're at university or just graduating for university and launching a great tech startup, we are looking for you and to invest the first check in your startup. And basically, I also take care about Genius Global, which is the first student-run association in France, and we're here to help you for free, young founders, to launch their ventures. So if you feel that you can get some money or get some help, feel free to reach out to me on LinkedIn or anywhere else. I'm free. Thanks.
Awesome. Thank you, Maxim. Philip, do you have anything to add?
I'll do the same then, Maxim. My name is Philip. Thank you very much for the invitation. Great panel. I'm part of the investment team at Join Capital. We are a fund based in Berlin, but we invest all over Europe. We have a very specific focus. We do only B2B and industry technology. So most of these topics, resonate. Although we only focus on software, but we do have one software in the semiconductor industry, so that was still very interesting. And we are more between seed and Series A, so our tickets go from a bit below 1 million to 2 million, and we help basically all these industrial entrepreneurs to tackle the German market at some point, because it's one of the powerhouses in Europe.
Okay,
yeah,
thank you. So with that being said, thank you so much for joining us. And just a small reminder that you have to fill up the forms with assessment. Thank you so much for joining, for finding the time. And what else to say? In 5 minutes, we're going to have another sector which is going to be devoted to platforms, marketplaces, and apps. So stay tuned. I'm going to be there to walk you through that. Thanks.